Hi everyone, welcome to section 1.3, slopes, rates of change, and linear functions. Okay, so still in this algebra sort of stage, but let's go ahead and look over the learning objectives for today. So it would be to find slope of a line given the equation of a line, find the slope of a line given 2 points on the line, find linear functions given the information about the function, and be able to find average rate of change of a function. So let's get started. So finding slope from the line, graph of a line. So what is a slope in general? So there's many ways you can interpret a slope, but really a slope is the ratio of the vertical change to the horizontal change encountered when moving from one point to another on a line. Let me rewrite that last part. On a line. Okay. And a slope can be positive or negative or just no slope in general. Okay. So it's a ratio, meaning that, it's something like A over B. Two numbers like over each other. Okay, so here is something called the wise up slope formula, right? So the slope of a line passing through 2 points, right? X1, Y1, and X2, Y2 is given by, I'm sure you've seen this before, right? Given by slope equals, sometimes it's written as like M, but what it really is Y2 minus Y1 over X2 minus X1. Y's up, right? Meaning the Y's are on top in this ratio. And vice versa, you can write it up like this. It could be Y1 minus Y2 and X1 minus X2. You will get the same exact slope using which one of these you prefer, right? It's really up to you. You get the same exact answer. Okay. Now, let's try an example. So find the equation of a line that passes through the points 4, 9, and 8, 1. Okay, so whenever you try to find slope in the beginning stages, I feel like it's always easier to denote like what your x1, x2, y1, y2 would be. So let's just say like this is x1, y1, and this is x2, y2. Okay, just to make it a little easier on us. So let's just go ahead and find the slope. Well, this says find the equation. This would just be slope, little typo there. But let's go ahead and just find the slope. So remember, slope equals y2 minus y1 over x2 minus x1. So here, what's my y2? My y2 is 1. So it'd be 1 minus what's my y1? My y1 is 9, right? That's why it's easier to kind of just pick in the beginning just to pick which one it would be so you're not thinking too much. And then what's my x2? My x2 is 8. And then my x1 would be 4. Okay. So this would be negative 8 over 4. And before we're going to finish that, let's kind of look to the graph over here. So this graph, it's very nice to us because it kind of tells us what's is going on. So if you see here, it looks like it has some type of vertical moving rise, -8. So here would be your rise. And then looks like it's going down -8, right? And here it looks like it has going over 4 units. So this would be a run, right? So remember, if you remember at all from algebra, right, it's really rise over run. And that's why we're talking about that. It's a ratio of your vertical change to your horizontal change, right? Our vertical change is -8. Our horizontal change is 4. That's our rise over run. And, we can just simplify this to -2. So our slope would be -2. Okay. So now let's go ahead and just find a slope given 2 points, right, without the graph. But it's just another example. So, this could be your x1, y1, x2, y2. That makes it easier to just plug it in. So here, the slope, remember, it's just, I could do it the other way around, y1 minus y2 over x1 minus x2. We would get the same answer anyways if we did the twos in front. But this would be 3 minus 4 over -1 minus 4. This is just -1 over -5, which is just 1/5. Okay, great. So now let's go ahead and check out some types of slope. So given examples of lines that have positive slope, negative slope, no slope, and undefined slope. So let's just go ahead and look at some generic examples. So for something that has positive slope, right? You could say is the line rises from left to right. Okay, so it looks something like that. It's rising from left to right. Okay, like you're going up a hill. So like up a hill. Okay, so this negative slope now is a line that falls from left to right. So it would look something like, something like that. If you're going, now you're going down the hill. You're going down. Maybe I can make this a little steeper. Something like that. You're going down the hill. Okay, so next one is no slope. Okay, and this is when we have a horizontal line. It looks something like this, right? There's no slope. You're not going up, you're not going down, you're just a constant straight line. It would be, you know, like you're just walking on a flat surface, right? You say flat surface, no slope. Okay, last one is undefined slope. This is when you have a vertical line, like a straight vertical line. And it looks something like this. Okay, so it's a little better. Okay, straight vertical line like that. Okay, and the reason why it's undefined is because there is a rise, but there's no run. So you would get something like some type of number. I'll do the actual number. you get something like 2 over 0, right? You're getting like an undefined situation because you can't have a 0 on the bottom. So that makes it undefined. So those are just different types of examples of slope, right? No slope and undefined slope are still considered slopes, but it's just whether they're not or undefined. Okay, so let's keep moving forward. So we have a new for this section getting into linear equations. So an equation with slope m and y-intercept 0 comma b, right? That's a coordinate point. Y-intercept is when, you know, when x equals 0, uh, crosses y-axis, right? All that terminology. Just a couple of reminders. But, you've definitely seen this before, but a linear equation would look something like this. Y equals mx plus b, right? Your slope times your x plus your y-intercept. So let's go ahead and apply this to some real numbers. So find the equation of a line with slope -2 fifths and y-intercept 0 comma 3 and graph the line. So we're not going to graph it, but what we have here is we know that the equation is y equals mx plus b, and we know that my slope is m, and I know my y-intercept is 0 comma 3, right? So this means m equals 2 fifths and b equals 3. So my final answer would be y equals -2 fifths x plus 3. And that's pretty much it. So now find the slope of a line y equals -2/3 x plus 5. So remember, y equals mx plus b. M is my slope, right? So this here is my m. So my slope equals -2/3. Okay, let's keep going. So here's another form of being able to find a linear equation. It's called the point slope form. Okay, so we've probably seen this somewhere too, but it's a equation of a line with slope m that passes through a particular point. And the formula for this is just y minus y1 equals m times x minus x1. Okay, so let's go ahead and put this to use. So find the equation of a line that contains the point 3 comma 5, has a slope of 4, and wants us to write our answer in slope intercept form, meaning like this. Okay, I guess I could write that too. That's y equals mx plus b. Okay, so we're going to use our point slope formula. So we have y minus y1 equals m times x minus x1. Okay, so this is my x1 and my y1, and this is my slope m. So we're just going to plug in everything that we have. So we have y minus 5 equals 4 times x minus 3. The y and the x are going to stay that way. The only things we input in are the y1, x1. But now it's just algebra and we just solve for this. So y minus 5, if I distribute it into 4, I get 4x minus 12. And then I'm going to add 5 to both sides. And what I end up with is y equals 4x minus 7. And that's how we use a point slope formula. Okay, so part B, we want to find, sorry, we want to find a point that passes through, or we want to find the equation line that passes through the points 8 comma 1 and 4 comma -2. Okay, so one thing here, if you notice, is that we don't have a slope yet. But how do we find a slope between 2 points? Well, we just got to use our wise up formula. So we got to use that. So let's go ahead and do that for this question. So, you could have your x1, y1 here, x2, y2 here. And so, we could do like step one, find slope. Okay. And so your slope is m equals, y1 minus y2 over x2 minus x1 minus x2. So this would be 1 minus -2 over 8 minus 4. And so you would get 3/4 for your slope. Okay. And now the second step is you need to choose a point to use your point slope formula, right? Here we have 2 points that we can choose from, but you need to choose one and then just be able to find the equation. So for the sake of consistency, I have 8, 1 as my x1, y1. So I'm just going to use that for these terms right here. So what I'll say here is I'm going to choose a point a, 1. I'm going to plug that into the point slope formula. So remember, it's y minus y1 equals m times x minus x1. So let's kind of go up here and fill the rest of this out. So this will be y minus 1 equals 3/4 times x minus 8. Okay. And you get y minus 1 equals 3/4 x minus 24 over 4. And, we could reduce this a bit, right? 24 divided by 4 is 6. And now I'm just going to add 1 to both sides. And I end up with 3/4 x minus 5. Okay, so that's that example. This part C, go ahead and try it out yourself and double check your answers in a sec. Okay. Okay, hopefully you got a slope of -2 between these 2 points using whichever way you want to go, right? It's definitely up to you. But you should have gone a -2. And when you choose a point to get your slope-intercept form, you could choose any point. I chose 4, -3, but you also could have chosen -2, 9, and you would have gotten the same answer, which would have been -2x plus 5. Okay, so once again, you have a lot of freedom into choosing what you want to use, right? Whichever x1, y1s you want, x2, y2s you want, whichever point you choose to get the final answer, but it's definitely up to you. But okay, that's it for this topic. We'll see you in the next video. Thank you.